Hi everyone, this is Ujjwal, partner Jyotsna.
Hello everyone.
We are here to speak about breast cancer. So, initially speaking, what the statistics shows us that for every 1 hour, there's a woman out there around the world dying due to the problem of breast cancer. It is statistically proven that 13% of US women are suffering immense pain and trouble due to breast cancer and its related issues. It is expected that 43,600 cases in a span of 1 year from now, and that number is plummeting to its summits. We have to take major decisions in eradicating these kinds of problems. So, to diminish these effects, initial in the old days, breast cancer detections, the main technology used is mammography. Mammography is nothing but testing women's private places physically, and these kinds of techniques are not being encouraged throughout the world. The main issue with this is society has different opinions on different kinds of procedures, and these being intimidating to women is not being accepted clearly around the world. So, to eradicate these kinds of problems and give women a hygiene and acceptable solution, we are turning ourselves towards the modern technologies like deep learning and convolutional neural networks to train the models and detect these problems with ease.
Neural network. A convolutional neural network is a deep learning algorithm which takes an input as an image in order to categorize and differentiate it one another. A convolutional neural network starts with a series of convolutional layers which creates future maps, which future maps are the outputs, which represents for which these future maps are the outputs or the components of input images. At the end you can see these are the fully connected layers at the end which interprets the output in order to categorize the picture. As you can see, it might be truck, van, or bicycle, in order to predict which category it belongs to. Now, as you can see, we have lots of advantages with the convolutional neural network. One of the main is it's the pre-processing that is required for the CNN is very low. And as you can see, the CNN, this in the picture you can see that the CNN has various hidden layers. The first one is the input which we are giving, and these is all the convolutional layer. There may be many convolutional layers. There may be many convolution based on the complexity of the image, based on the complexity it required, and that is how we have the layer. And with each convolution layer we need to specify how many filters we need for each convolutional layer. So now what is a filter? If a filter is filters are the patterns which we get through the picture. Let's take an example. Now we can see image of a bird. Now we have to categorize whether which bird it belongs to, which category of bird it belongs to. As we can see, there are in a bird we can see that this beak is very unique. So with the help of this beak we can detect that the bird belongs to this category. So this can be helped, this beak can be helped as a unique feature in order to identify the particular one. Now with each convolutional layers we can with these filters we can get the patterns, and we can detect the patterns. Now now if in this picture we can say it might be not only a beak. We can take the texture of the bird, or the number of feathers it has, or the based on the marks it has. We can take these all aspects as an input, and we can categorize them, and by categorizing them we can identify that this belongs to this. That's how it is. As said, the first layer is responsible for capturing a low level features such as edges, colors, gradients, orientation, etc. With added layers, based on the complexity of the picture, based on the segregation or the categorization, the architecture adapt to high level features as well, by giving us a network which has a wholesome understanding of the images. As you can see, the next layer is the pooling layer, which is responsible for the spatial size which is used for reducing the spatial size of the convoluted picture, the feature map, which helps in decreasing the computational power required to process the data through dimensional reduction. In this project, we are using DenseNet CNN for detection of breast cancer. Now, you people might be thinking, what is DenseNet and why are we using DenseNet and all? So, DenseNet is a type of convolutional neural network that utilizes this dense connection between layers, and where we connect all these layers directly with each other. So, in each layer obtains additional inputs. As you can see, each layer obtains all these features, additional inputs from all these preceding layers, and pass its own to the subsequent layers. So why are we specifically using DenseNet here, and how is it different from standard CNN? Basically, in standard CNN, input goes through multiple convolutional layers in a step-by-step manner and obtain the high level output or the features. But in DenseNet, each layer obtains additional inputs from its preceding layers and pass its own to the subsequent layers. Since each layer receives future maps from all these preceding layers, the network can be thinner and compact. That is, the number of channels that were required for predicting the output can be lessened. So what are the advantages? Why are we using DenseNet over any other one? So the advantages are that it has a strong gradient flow. So now, as I said, the future maps can be assess the two different birds. The common feature is the beaker, but the thing is, the beaker is placed at different places. For each bird, the beaker is in a different position. So based on the position of the beaker also, we can say that the category of the birds can be described. So that is how we use the CNN and the DenseNet to identify, to categorize the things. The same technique and same patterns are used for detection of the breast cancer. Here we provide the various data sets to identify whether a person is having a breast cancer or not. We can see that here are the different samples. So we train the model by providing the various data sets and derive the patterns, trends, and classify that the people are having a breast cancer using this AI technique.
So we are done with the introduction part and the algorithm explanation of what we are doing in this particular project. So now let's execute the code in front of you. So these are the libraries that we have used for this project to work it completely. We have used the Keras models for the image recognition and the TensorFlow libraries as well. And then coming to the data pre-processing, actually in data science, in artificial intelligence too, while for the classification problems, there are three different types of steps. One is the data pre-processing, and the second is the training the model, and the third is testing the model and building some predictions of it. So we have created four types of variables which are known as Bennigan, Mulligan. So we have created a test and train variables for each and every type of cancer. For importing the particular images, we have created a small function known as data importer, which does nothing but we have segregated those images into the corresponding folders such that we can get a clear value of the model what it is currently taking in, and 400 different types of images in different shapes and sizes. And we got this dataset from datafree. So that's for the data pre-processing, and next comes the test and train evaluation scripts. As I know, we have around 400 different types of images in different shapes and orders. To better use it, we have segregated it into different parts, which is nothing but test part and the training part. We are segregating the images as well into 80-20 ratio, 80:2 ratio for the test and train, And for sample wise, we are displaying some images from benign as well as malignant as well. So, yeah, what is a data generator? You must be wondering, right? So, data generator is nothing but each and every image, it'll be shuffling through the images as well. I mean, for a better training model, in some perspectives, because the model will be exposed to different types of images as well as different shapes as well. It takes the existing images, rotates it on an x-axis or y-axis through certain degrees such that the model will be better trained and it will be able to classify images efficiently and accurately as well. So, as discussed by my partner, DenseNet is something that we are using in this project. We have run this types of images through VGG classification, DenseNet, and CNN as well. DenseNet. DenseNet, as my partner told you, it consists of different types of layers and feature extraction and filters as well. So what this build model does is it initializes all these types of layers into it, like global average pooling, dropout, batch normalization, dense, and etc. And builds a model. It's nothing but a pre-described model. This pre-described model, we have to pass our images into it. So to make that happen, we have to first initialize the DenseNet model into a variable with custom weights and a few parameters, and this model will be sent into the this particular function to add these particular layers into it, and the learning rate also is assigned here. So the summary of it. So next coming the learner rate reducer. In our project, what we have done is at a particular time, the model will be converging. It's like while training the model at a certain specific time after looking after 200 or 300 images, there'll be a stage where the model will be completely converging. Like we have no use but a wastage of computational power if we keep feeding the model more and more and more of images. So at this particular time, we have to stop the model from training furthermore, as we know that overtraining a model is also hazardous, and other values like whatever the features, essential features required for classifying the images will be extracted, and the model will not be learning anymore. At this stage of time, there's nothing used but stopping. We can't overtrain the model, right? So to eliminate these kind of issues, we have used this inbuilt reduce LR on plateau. The training generator, which takes in the xtrain and the ytrain variables. The xtrain consists of the benign images and the malignant images, and ytrain consists of the labels. Which image is corresponds to which particular label. That's the ytrain. And then we have initialized the number of epochs in each particular, the steps involved in each particular epoch. And then comes the validation data on how we can conclude that whether the model is correctly predicting or not. And there are some callbacks, which are nothing but the learning control. As I told you, it's the learning rate reducer and the checkpoint. So with the help of all these functions that we have initialized before, the model will be executing. And if you could see, these are the list of epochs that we have run. So based on that, we will be plotting a history, which is nothing but the accuracy. We'll be plotting a graph between accuracy and value accuracy. Accuracy also increases. That's what this particular graph is telling us. And at the same time, there's the loss function. The model training at each and a particular step, the loss function is also decreasing as it. The next comes the prediction part. In data, we are getting an approximately accuracy scores of 86%. Now we are testing the same model with the help with the test data. Created a confusion matrix to better understand our results, and listing the total true positives and the false negatives and the true negatives as well. So if you could see the true positives 79, and negatives. We have the ROC curve, which represents the true positive rate, and the AUC value, which comes around 0.9. We ROC ROC log value, and the finally we are displaying some images whether the predicted results and the accurate results are matching or not. That's as I told you, we'll be showing you the VGG net as well. This is the VGG net model final values. We could see here the train loss, I mean, the value accuracy is not as par as compared to DenseNet. So that's why we are sticking with DenseNet only. So that's a project. Thank you.